So you can go 9 into 297. 27, 27. Okay, so x equals 3 plus or minus 3 root 33 over 4, and nothing can cancel, as good as it gets. So, are these x-intercepts of this? The way I wrote them, is that an x-intercept? No. What's an x-intercept? 0, 0, and 3 plus 3 root 33 over 4, and 0. How do I get a y-intercept? I was supposed to say plus or minus. Okay.
Wait, we can do that. We can say plus or minus for an x-intercept.
Yeah.
Say
In one bracket? So just 2 points in one bracket?
Yeah.
I could enter that on my graph desk.
All right. So we want a y-intercept. I wouldn't show you something you can't do.
Okay.
So our y-intercept x equals 0. So we get f of 0. You can do it this way. On my own test, I would never. I would write them both up because I'm an overwriter. I would like spread everything out nicely. I would put x-intercept. I would put a box around it, possibly in a cloud shape, and probably in a different color, because that would be how I would roll. All right. So f of 0, 36 times 0 plus 3 times 0 squared minus 2 times 0. Did I actually have to do this?
Yes.
I already had it. I already have it over there. I'm just proving a point because people will still find it every time. All right. Now what I want you to do is I want you to get me, using the first derivative, maxes and mins, and increasing and decreasing intervals. Go. So we have f prime of x equals what? 36. What? Plus 6x minus 6x squared. Then I can take out a negative 6, and I'm left with x squared minus x minus 6. And then I get negative 6, x minus 3x plus 2. And then I would say x equals 3 and x equals negative 2. And then I would say those are the critical numbers of my first derivative. Now the critical numbers of the first derivative give me what? Maxes and mins, and sometimes points of inflection if it goes from increasing, decreasing, right? So you have to watch yourself. So we go to our number line. We have our number line. It has negative infinity and positive infinity. Why do I have these on the number line? And not like 7 and 4. There's no restricted domain, and it's a polynomial, which means it has a XER domain, negative infinity, positive infinity domain, right? So that's why I put those on the end. If it's a radical, you could have a restricted domain. We agree?
Yes.
All right. So we have negative 2 and we have 3. Then I run test points, so I could do like negative 3, I could run 0, and let's say 4. And where do I run them into? Where do I put those points into? F prime. If I put them into the original, I'm just getting a point on the original. Does that help me if it's increasing or decreasing?
No.
No. So F prime. Now remember, I always plug it into this factored form because it's easier. So I get negative 6, negative 3 minus 3, negative 3 plus 2. So I get a negative times a negative times a negative, which gives me negative. Okay, then this one, I do negative 6 times 0 minus 3 times 0 plus 2. which is a negative, a negative, and a positive, which gives me a positive. And then I do negative 6, and then 4 minus 3, and then 4 plus 2, which gives me a negative, a positive, and a positive, which gives me negative. So I have decrease to increase, increase to decrease. So I have a minimum at negative 2 and something. How do I find that something? So I'm going to go f of 2 to show them that I know what I'm plugging it into, correct? And so I'm going to plug it into 36, I don't remember what it was, 36x plus 3x squared, is that what it was?
It's a negative.
Good call. Plus, what was the last thing?
Minus 2x cubed.
And what do we get for this one?
44.
All right. Maximum.
Just find it funny.
So it is at negative maximum. It's not a freaking maximum. It is a minimum. Oh, I did it already. Maximum. It's at 3 and something. So I get f of 3. 36 times 3 plus 3 times 3 squared minus 2 times 3 cubed is what? Pardon? 8. Okay, then if I say intervals of increase, decrease, intervals of decrease are negative infinity, negative 2, union, which means or, through to infinity. Intervals of increase are negative 2 to 3. So that's if I give you an equation, yes? Okay, what if I give you a graph? We're going to come back to this one, leave space to finish concavity for this. We're doing a whole nother side thing. So separate paper. This is f of x. Just the graph of f of x. We agree? This is what we've always looked at. If I ask you for maxes and mins, where would they be? The max would be here. The min would be here. They are where they are. We agree? Okay. It would be increasing here and here. That would be where it increases between, correct? From negative infinity to A, and then B to positive infinity, right? And then it would decrease from A to B. Those are easy when it's f of x. You can literally see where increases, decreases, maxes, and mins exist, yes? Okay. Not the same graph at all, giving you a different graph. This is f prime of x. You need to wrap your head around what does f prime of x give us. We just went over it. Maxes and mins when what? So when f prime of x equals 0, we get maxes, max, min, or point of inflection technically. Point of inflection if it goes increase, increase, decrease, decrease. Yes? Now, how do we know when it's increasing? F prime of x is what? For increasing. Positive, so greater than 0. It's increasing. And where f prime of x is less than 0, it is decreasing. Is any of that different than what you've known so far? No, that's nothing new. So we are going to look at this graph. We're going to say that this is A, this is B. Okay? So, where is this graph increasing and decreasing? This one. Intervals of increase. Some people will say to me, well, I don't know what the minimum is. I don't actually care what the minimum is. Negative infinity to A and B to positive infinity is completely correct, but why, Alyssa?
Because it's increasing where it's positive, so once it's A, it's negative, and then increasing.
Yeah. So we're not looking at the physical graph. You have to stop yourself from seeing that the physical graph is decreasing here and increasing here, because that is not the rule. We're not looking at f of x, we're looking at f prime of x. Where f prime of x is greater than 0, which means y is greater than 0, is where my graph is going to increase. Yes? So where is this graph greater than 0? Here and here. This is where it's less than 0. Yes? It's not actually, you have to bypass that your brain wants to look where it's increasing, which is from this minimum to there. It's not at all. And this is not the f of x graph. This is the first derivative graph. And where we have intervals of increase is where this first derivative graph is positive. And it's positive from negative infinity to A and B to infinity. Now where are the intervals of decrease? A to B, because that's where the graph is below the x-axis, right? Where do my maxes and mins occur? At A and at B, because that's when f prime is equal to 0, correct? So I know, can I give you what the y value is though? Could I tell you, from this graph, could you say the maximum is A and this and B and, no, you can't. You can just say it occurs at A and it occurs at B, but you can't give any more information, there's not enough information. So, I know that I have, it's supposed to be an x equals A, and I have an x equals B for this graph over here. Now, it's above, so what's it doing up here? Increasing, and it's below, so what's it doing down here? So what happens when I increase on the right of A and decrease on the right of, increase on the left, decrease on the right? It's a maximum. So at x equals A is a maximum. What about B? On the left of B it is decreasing because it's below, and on the right of B it is increasing, so it's a minimum. You have to let go of the fact that that is not f of x. You have to let go of the fact that you see a minimum on that y-axis and you want to state it, but that is not a minimum. That is the minimum on the graph of f prime of x, yes? If I asked you what's the minimum on the graph of f prime of x, you would tell me the actual minimum. If I ask you what's the minimum on f of x, you can't give me that minimum. Do you know what I'm saying? All right. Another one. Yo.
Oh, I was gonna say, how did you see like the increasing and decreasing again, like for the max and mins for A and B? Like the curves, how did you make that? Like you said for the value.
Well, what's this represent up here? What does the y up here represent? What do positive values on the first derivative represent? So what's it doing on the left of A? Increasing. And what's it doing on the right of A? Decreasing. Do you see what I'm saying?
Yeah.
Yeah. So you have to think of when it's above, it's increasing, it's increasing, it's increasing. When it's below, it's decreasing, it's decreasing, it's decreasing. That's what that graph, that's what the above represents. If the above represents increasing, the below represents decreasing. Not positive and negative, increasing, decreasing. If you can wrap your head around above is increasing, below is decreasing on the first derivative, you'll find this really easy. Okay? Does that make more sense?
Yeah.
Okay. So, let's look at this one. Now you'd have to, if I just drew a graph, you would have to say, Mrs. Lepp, Is that f of x, f prime of x, or f double prime of x? And I would say, well, this is f prime of x. And if this is f prime of x, I don't want the mins and maxes off of it, or the increase and decreasing off of it. I want the max, min, increasing and decreasing intervals of what do you think? F of x. I know. So we have, we're going to say A, B, C. Where is this graph increasing? A to B and C to infinity, because this is where the graph is positive, right? We really care about where that f prime of x is positive. Where f prime of x is positive, we have increasing. So it's from A comma B or C to infinity. Okay, it's decreasing here and here. So it would be from negative infinity to A or B to C. Where do I have maxes and mins at? A, B, and C. Now if I looked at my number line, remember I could turn this to a number line if it made it easier for you to visualize it, right? We could turn it to a number line. Take this x-axis completely down. This is negative here, right? This is positive here. This is negative here. This is positive here. Remember, you can take the x-axis down and make it a number line, which often makes it easier to see increasing and decreasing maxes and mins. Yes? So this is decreasing to increasing. This is increasing to decreasing. This is decreasing to increasing. So I always like drawing them out as a number line. Take the x-axis, bring it down, and write a number line for myself. It makes it easier for me to visualize it personally. You can keep the graph if you like. So A is a minimum. So we have minimums at x equals A and C, and we have maximums at x equals B. So this will be a min, max, min. Now, if this is an x cubed graph, what was the original, guys? X to the 4, which does have a min, a max, and a min, or a min, a max, a min, and a max, or point of inflection and max. What would the next one be? Just a quadratic, right? Just be a quadratic, because when we do the derivative of a cubic, we get a quadratic. Okay, try one more. Photocopier.
Oh, yeah.
You've just heard it now. It's been going for like the whole year. A
Honestly,
little late
yeah.
to the game, Jonathan. A little late to. Because you guys have been quiet once in your life, and it's today. Normally, not quiet enough to hear it. Yes. Increasing, decreasing, max, mins, go.
I used to photocopy like 3,000
F prime of x, and I want the information off of f of x. So we have A. Awesome. Just get it out of okay. A, and then whatever this asymptote is, we'll call it negative. Sure, we'll call it x. You spoke first, you get it what you, and then we can't make it y because that would be
W.
x2. X1. Okay. So we have an open dot at x1 on the number line. Then we have a B. We have a C. We have an open dot at x2. And we have a D. We have a negative infinity, and we have a positive infinity. Now let's fill some crap in. What goes between negative infinity and A? A positive, which means increasing. Then A and this asymptote?
Decreasing.
Decreasing. This asymptote to B?
Decreasing.
Decreasing. It's below. B to C?
Increasing.
Increasing. C to Asymptote,
Decreasing.
decreasing. Asymptote to D,
Increasing.
and then D to infinity.
Decreasing.
So all we're doing is positive, negative, negative, positive, negative, positive, negative, right? That's all we're doing. The positive and negatives represent the y values at those spots. Yes? So this would be increasing from negative infinity to A, or B to C, or x2 to D. See how it's round? Because it can't equal x2 because x2 is an asymptote. Decreasing from A to x1, or x1 to B, or C to x2, or D to infinity. Where are my max and mins going to occur, or points of inflection? A, the B, the C, the D, right? And we look directly on both sides of them. So on A it is increasing, then decreasing. On both sides of B it is decreasing, then increasing. On C it is increasing, then decreasing. On D it is increasing, then decreasing. So we actually have 3 maxes, 1 min. Because positive means increasing, negative means decreasing, right? They're asymptotes. You can't have a max or min in an asymptote, right? An asymptote's an asymptote's an asymptote.
Let's go from increasing to decreasing out of place if there's no max or min.
What are you talking about?
Like that actually goes from decreasing to increasing. How does it switch directions with no max or min?
Increasing, decreasing.
Like if that's on the graph of f of x, or what about, or on f prime of x, would it be the same on f of x?
Your asymptote's the asymptote.
Oh, okay. Thank you.
Because they're undefined, right? You can't have an undefined, your f prime of x has to equal 0, not undefined to get it correct. So we would have a max at x equals A, C, and D, and a min at x equals B. I've never seen something this ugly ever given to you. I just want to see. They have to give polynomials.
Would you draw like a inflection hump, like make a picture between the A and the B, and show A like positive to negative, or the negative to the negative?
Sorry, I don't know what you're asking.
Okay.
What?
Is it?
No, I'm serious. What are you asking? I just don't understand what you're asking.
No.
Like, I want to help you, but I don't know what you're asking. This is an asymptote at x1. This is an asymptote at x2.
I'm talking about your little number line.
Yep. What are you
Like
asking?
when you're drawing the picture, yeah, the x1.
It's an open dot.
From positive to negative for D, and then positive to negative for C as well. So that's including the asymptote.
Nope. There's a positive in here. Negative here. Here's my asymptote. An asymptote's an open dot. Because it doesn't exist on that number line. Asymptotes don't exist, right?
Yeah.
So there's an open dot here. So on both sides of the asymptote, I know it's decreasing and decreasing. So I know it's coming into this side of the asymptote, it's coming into this side.
So maybe not draw like a picture to that, because we're just trying to find a map here. It just doesn't exist. Because this one, we can always say the x, what it's letting us know which side is positive, which side is negative.
It's just telling you how the graph actually changes.
Like, I would just draw something that is positive here.
Okay, back to this page. We're doing second derivative. So, Okay, so the second derivative back on this page, if the first derivative is 36 plus 6x minus 6x squared, the great thing is if you see a polynomial and they start asking you the first or second derivative, life is good because the polynomial gets smaller, so it's less x's, less information. If you see a rational, you'll be like, oh, really, it sucks. It really does. So do radicals. But polynomials are much better. So the 36 goes away, the 6x turns to a 6, and the 6x squared turns to a negative 12x. Now where f double prime of x equals 0 is where points of inflection occur. So that means it's where concavity changes. So it's where that second derivative equals 0. So if I want to know where the points of inflection are, I would go 0 equals 6 minus 12x. Subtract 6 from both sides. Negative 6 equals negative 12x. Divide by negative 6. X equals, try again, what the heck? We're all in the same boat, it's fine. I don't know what happened either. So we're at negative 12x, we're going to divide by negative 12. So x equals a half. You could add the 12x over, you'd still divide by 12, and you'd still get a half.
Oh, yeah.
Yeah. So we have ourselves a number line. Once again, it's negative infinity, positive infinity, because the original was a polynomial, which gave us a domain of that, which is why we always look for a domain first before we do anything. And then the only number we have on this number line is a half. Now the greatest thing is, where f prime of x is greater than 0, we have increasing. Where f prime of x is less than 0, we have decreasing. Yes, we just talked about that. Where f double prime of x is greater than 0, we have concave up. And where f double prime of x is less than 0, we have concave down. So now we just have to run test points, but our test points go into which equation this time? F double prime. So we have a half, so I'm going to do a test point of 0 and 1 into f double prime, which I can just put it into the 6 minus 12x. So I go 6 times 0 minus 12x. This is f double prime of 0.
6 minus 12x.
Oh, good gosh. 6 minus 12 times 0. So it's 6. So what is this? Positive, which is concave up. Then f double prime of 1. Please don't assume it will be concave. It could go concave up to concave up. It could go concave down to concave down. There's no such thing as... Now, on polynomials, it'll often do it, but we're not always just looking at polynomials, right? We're looking at other graphs. Now, this one we plug in 1. We get 6 minus 12 times 1, which equals negative 6. So that would be 1 and negative 6 on the second derivative graph, right? Which would make it be negative, which would make it be concave down. So I have concave up from negative infinity to a half, and concave down from a half to infinity. And I have a point of inflection at 1/2 and what? How do I get the other number?
Plug it into the equation.
Plug it into the original because it comes off of the original, right? Which I don't know what the original is. F of x equals 36x, I think. What's the rest? My brain stops. What's the original?
Plus 3x
3x squared?
minus 6 cubed.
Thank you. That's an 8. Can you see it? Can't clean it up. See? My pen quit in the middle. But yeah. Oh, put it. Okay. So, going back to what we did before, if I gave you this now, if I gave you f double prime of x, this is A, that's B. If I give you f double prime of x, what does the A and B give you? Points of inflection. Because they are where f double prime of x equals 0, we get points of inflection. So in this case, they would be at x equals A and B. So we have a number line. It has an A and a B on it. That's where my point of inflection is. This is a f double prime number line. Sometimes you might want to write that beside so it gives you a little reminder of what the pluses and the minuses give you, because it changes. F prime of x gives you increase and decrease. F double prime gives you concave up, concave down. Ooh, I don't know what you said. So, on the left of A, is it positive or negative? Negative. Now, some people say it's positive, it's increasing. No, no, it's just literally the sign. It's like, don't think of what the graph looks like. Look at what the signs are. What are my y values on the left of A? Negative. So I put a negative here. What are my y values between A and B? I don't care if they're going up and down. What are all of them?
Positive.
They're all positive. And then what about the ones on the right of B? They're all below, so they're all negative. So you could tell me that this graph is concave up from A to B and concave down from negative infinity to A or B to infinity. So they give you an equation, or they can give you a graph and ask you information about the original graph. Textbook, can I still see the textbook? Oh, that's a cold textbook.
Yeah,
It
it's
didn't
been
have a home in your car?
Yeah, that's where my bag was.
It's like chilled.
It's nice on my hands.